Hi guys, welcome to today's lesson. So today we're going to be focusing on factorizing rules. Now I know guys that factorization is one of those concepts in mathematics that gives you a little bit of a problem. But right now with these rules that we're going to do here and with you tuning in so that you can see everything that I'm going to do, then we're going to remedy that situation. But for now, let's just see what is our leading question for this particular lesson that we're going to have now. So, have you ever thought about how can you then reverse the process of expanding algebraic expressions, right? When you talk about expanding algebraic expressions, remember the commutative property and the associative property, right? When you have all of those and you are multiplying and dividing, how can we then reverse that? That's what factorization is, right? It's reversing the expanding process. Now, what you're going to look at, remember, firstly, we've looked at our expanding terms, which was the 3 different types of expanding forms. And then now we're going to look at factorization, which has 4 types of factorization. It's a common factor, a difference of squares, a trinomial, and cubes. The keywords for this lesson will be, firstly, we need to understand what is a factor. From a factor, we then say, how does a factor become common? Lastly, what will then be a binomial? Remember from the previous lessons that we've had. Now, a factor will be when 2 or more terms are multiplied together to then form a product, right? So 2 or more terms, we then call them factors, right? So when I'm talking about a factor, rather, as a singular, it will then be a number that is divisible in another number without leaving a remainder if we wanted to maybe describe it. But now, under factorization, if I have 2, 3, and 5, and I'm multiplying all of them, they will give me 30. That will therefore mean that 2, 3, and 5 are the factors of 30. And then each of the terms multiplied is a factor of the product, as I just said. Now, the concept of factorizing is the process of finding all the factors of a given product. Going back to the example that I just gave you, if I give you 30 as the number and I say to you, factorize this, you finding all the factors that I need to multiply in order to get this 30 will then be the process of you factorizing this particular number. When finding factors of a number, we divide the product, right, by the prime numbers until we have identified all the prime factors. Now here, guys, before we go anywhere, we need to understand the concept of prime numbers, right? Remember, a prime number will be a number that has 2 factors, 1 and itself. So for you to say a number is a prime number like 3, it is because only 3 and 1 are divisible in that number. 6 will never be a prime number. Why? Because 2 is divisible, the 3 is divisible, 6 is divisible, and 1 is divisible. So we need to understand this. And I think you guys actually did this when you did your ladder method and your tree diagram method of prime factorization when trying to find a product of a number in terms of its prime number. So that's what this is all about. So always try to divide by the lowest prime number until you get to all of the prime numbers. So your last answer must be 1 at all times. So write the number 24 as a product of its prime factors. Remember, that is the question that we used to do previously when we were doing our mathematics. So to do that, I will divide by the lowest prime factor. And the lowest prime factor of this will be 2. So it means I will have 24 there. And then if I divide 24 by 2, 2 goes 12 times there. I continue again and divide by 2 because it's the lowest, and that goes 6 times. I will continue again and divide by 2, which will go 3 times. And then lastly, I will divide by 3, which goes in once. So it means that 24 is the same as 2 multiplied by 2 multiplied by 2 multiplied by 3, right? Remember I said your final answer must always be 1. This is the one that I was talking about. If you do not have 1 here as your last quotient when you are dividing, then you haven't found all the prime factors of that particular number that you would have been given at that time. Now, there are 4 ways to factorize, as as I showed you on the mind map. The first one is a common factor. The other one is the difference of squares. And then we have what we call a trinomial. Remember when it has 3 terms. And then lastly, it will be sum or difference of cubes. Factorizing algebraic expressions, one thing that you need to make sure is you recognize the pattern for the different types of factorizing. So firstly, you need to look at, are the exponents decreasing of the variables as you move from left to right? If yes, then there's a possibility it might be a trinomial. Or is the variable appearing in all the terms that I have? Then that will be a common factor type. Each of these processes are the reverse of expanding, right? So for example, if I say I have 2x plus x, you can see that this is the same as me having x as a common factor, then I will have 2 plus 1 there, right? What does this mean? If I wanted to expand this, I would multiply the x with the 2, I would multiply the x with the 1, which will go back to what I initially had. Hence, this is a reverse of expanding. The last thing you always need to make sure when you are factorizing, you check that you have factorized correctly by expanding the factors, right? So in this example that I just gave you here, if I want to test, x multiplied by 2 will give me 2x, and then x multiplied by 1 will just be x. And then you can see it gives me the terms that I had initially when I started. So guys, there are 4 types of factorization. You're going to get into great detail just after the ad break. But for now, what I want you to think about is, what is different between you factorizing using a common factor and you factorizing using a trinomial, right? Which is your difference of 2 squares or just a normal trinomial. Think about the difference between that. And how do I then see it with my eye when the question says this? How will I see that this is a common factor and this is a trinomial or a difference of squares? Think about that just as we go to the ad break, and when I come back, we'll then get into great detail of everything that I've just said so far. Hi guys, welcome back from the ad break. So I hope you've been really giving it a thought as to what exactly is the difference here. How do you then see it with your eye? When I give you a question, how do you decide which method to use? But for now, let's just look at what a common factor is first, and then later on we're also going to look at what is a trinomial, and then we can then make this comparison that I said you must be thinking about during our ad break. So remember that when you talk about a common factor, this refers to a factor that appears more than once in 2 or more terms. Now when we say it appears more than once in 2 or more terms, it must be in all the terms, right? Because if it appears only on the first 2, then you will need to only take a common factor for the first 2 terms and leave the rest of the terms. But if it appears on all of them, then you can take out a common factor for all of them. Just make sure that if it appears on the first 2, you don't put everything else in brackets, but only taking the common factor for the first 2 terms. Please make sure that you do that. I will show you exactly what I mean by this. Now, the second thing is, you always look for a common factor when factorizing an algebraic expression, right? Most of the time, when I did not give you an equal sign, you always start by looking for the common factor, and then you can continue with the rest of the other methods. Now, what does finding a common factor mean? It actually means that you are dividing each term by the highest common factor. The highest common factor of 2a rather, plus 4 will then be 2, right? 2 is a number that is divisible in 2a without leaving a remainder, and 2 is a number that is divisible in 4 without leaving a remainder. So the process of me finding what is written here on the right-hand side, what I will then need to do, I will take the first term, you divide it by the highest common factor. This will just give me a. That's the first term I write inside the bracket. I will take the second term, you divide it by the HCF, which is the highest common factor, and that will give me 2. And that will be the next term that I have there. And then my common factor will be what is outside the bracket. Remember, I said always try to expand in order to see whether you have done the correct thing or not. If you do that, 2 multiplied by a will give us 2a, plus 2 multiplied by 2 will then give us 4. So you can see that this is the same as what we had as a question. Because remember, I said factorizing, excuse me, is the reverse of expanding. So it means if I expand, it must take me back to what the question was. Let's look at maybe some more complex ones where it's just variables the most. I have m squared minus 3m. The highest common factor here will be m, right? Because it's divisible in m squared and it is also divisible in 3m. How do I then get this thing that is written, the equal sign here? I take each term, divide it by the highest common factor. Let's start with the first one. M squared divided by m will then give me just m. And if I take the 3m divided by m, it will then give me just the 3. Hence, inside the bracket, I have m and I have 3 there, and then the m outside. Again, test whether your answer is correct or not. So m multiplied by m will give me m squared, minus m multiplied by 3 will give me 3m, which is the same as what the question was. So that's how you then test your answer, whether you did the right thing or not. Now also, what if now the common factor is a variable and a coefficient, right? Meaning a variable and a number as a term. So this one, the common factor will be 2a. How do I get my answer again? Remember, the first term, which is 4a squared, you divide it by 2a, and this will give me, the 2 goes in there twice, the a cancels 1a there, and I'm left with 1a. Right? And then you can see there I have 2a, and it's not supposed to be just a, it's supposed to be 2a there. And then lastly, if I have 6a divided by 2a, the 2 goes in 3 times, the a cancels the a, and I'm just left with the a. So the actual answer here, guys, is 2a into 2a plus 3. Right? So please just make sure that you correct that. Again, you test your answer whether it's correct or not by doing what? Expanding. If I multiply the 2a with the 2a, it will give me 4a squared. I multiply the 2a with the 3, it will give me 6a. And that will therefore be my answer that I initially had as the question. So at all times, guys, it doesn't matter how many terms you are given, right? As long as you took out something as a common factor, each and every term that you have will need to be divided by what you are taking out as a common factor in order to then write whatever that you get inside the brackets. Because if you don't do that, then if you expand, it will not take you back to what the question was initially before you took out the common factor. So please do make sure you do that. Now, remember we said there are 4 ways to factorize to identify a common factor: the difference of squares, trinomial, the sum or difference of cubes, right? Now, if I have a perfect square minus a perfect square, we now call this a difference of 2 squares. So some people normally call it dots, right? They use DOTS to mean difference of 2 squares. At all times, it must be firstly a perfect square with a minus and another perfect square. So a squared is a perfect square, b squared is a perfect square, there is a minus there, therefore this is a difference of 2 squares. Now, why are we calling it a difference of 2 squares? It means that your 2 brackets that you're going to open, they will have both terms that are identical in both the 2 brackets. The only thing that will be different will then be the signs. One will always be a plus, one will always be a minus. It doesn't really matter which side has a plus and which one has a minus, because the brackets will be identical to one another at all times. Remember, difference of 2 squares, perfect square minus another perfect square. And then that's how you gauge yourself with whether it's a difference of 2 squares or not. So, to factorize this, I find the factors of a squared, which is a and a. I find the factors of b squared, which are b and b. So the brackets will have both a and b, a and b. The signs will be different. It will be plus and it will be minus. At times it can be minus, it can be plus there. It doesn't really matter because the brackets are exactly the same. Now, when you are trying to identify a difference of 2 squares, you need to check whether there is a common factor first. That's where you always start. That's why I started with a common factor. Also check if there is a difference of 2 perfect squares, not just any squares, it must be perfect squares, and then take the square root of the perfect squares, right? So here you can see a squared minus 16, is there a common factor? No. So the first step, meaning we don't take out a common factor. We look at the second step. Check if there is a difference of 2 perfect squares. A squared and 16, are they perfect squares? Yes. Is it a difference? Yes. Therefore, it means this is a difference of 2 squares. Lastly, you will take out a square root of each term, which will then be your factors. Now, here, you see, the mistake that one would make will be to use 2 and 2. Why? Because the square root of 16 will be 4, and then a person will assume that because the square root is 4, then I must use 2. But that's not the case. You must use the actual factors of the 16. So the actual answer here will be A and A. For 16, it will be 4 and 4, and then lastly it will be plus and minus, right? Remember, it can also be minus and plus. It really depends on how you want to then do it. Also, let's look at another example. Remember, start with a common factor. 4a squared minus 16 is a common factor? Yes. Common factor is 4. So I must take out a common factor of 4. If I do that, I will say it's 4a squared divided by 4, which will give me just the a squared. And then I will say 16 divided by 4, which will then give me 4. So what does that mean? My common factor is outside the bracket. I will have a squared minus 4, which are the terms that I got there. Inside the bracket, is it a difference of 2 perfect squares? Yes, because it's a squared and 4. So I need to find then the factors of a squared, which is a and a, the factors of 4, which is 2 and 2. And then my signs will be plus and a minus. I really prefer always starting with a plus, because then it sets the tone that the next sign definitely needs to be a minus if it's a difference of 2 squares. So that's just one thing that you can look forward to, because I really personally believe that starting with a positive kind of sets the tone for me, and I will be able to do the others. But remember, it can be minus and plus, it doesn't really matter. Now, this is an interesting one, right? Is it a difference of 2 squares? We are yet to find out. Firstly, we look at the common factor. But I know that as soon as one sees this plus in the middle, they will automatically think that this is not a difference of 2 squares because we are adding, right? Because what did I say? I've been saying it must be a difference of 2 perfect squares. But if you take out your common factor of -4 here, you will then see that it will now give us the minus that we need in order for it to qualify as a difference of 2 squares. So -4a squared divided by -4 will then give me a squared, which is a positive, and then positive 16 divided by -4 will then give me -4. And then you can see that in the brackets there will have a squared minus 4. Outside the bracket I will have -4. Now, one thing that I should warn you about here, most people, after taking out the common factor, they feel this urge to then multiply the number back. But if you multiply it back, it takes you back to what the question was. So it's like you're just working in reverse and you're not doing anything productive at that time. So please always make sure that you deal with your nerves and you don't just do things because you are used to, if it's brackets, multiply. If it's brackets, multiply. That's not always the case. Just make sure that you do the right thing, please. Now, to factorize the thing that is inside the bracket there, it will therefore be a squared, right, which is a, and then 4, which is 2 and 2. Remember, my personal belief is always start with a plus and then end with a minus. But you can work it out anyhow. Now, let's quickly go to all these questions that we've done thus far. Remember, I said you always need to test whether your factorized version of the answer will give you the original question. Remember, a multiplied by a will be a squared. We use FOIL, remember when we spoke about expanding. A multiplied by b will be minus ab. A multiplied by b will be ab. And then lastly, it will be minus b squared. Then you can see the middle terms will cancel. I will be left with a squared minus b squared. Right? So it does take me back to that particular question that I had. Let's look at this one here quickly. A multiplied by a will also give me a squared. A multiplied by -4 will be minus 4a. 4 multiplied by a will be plus 4a. Lastly, 4 multiplied by -4 will be -16. Let's look at the middle term. Can it be cancelled? Yes. Minus 4a plus 4a is 0, so I'll be left with a squared minus 16, which takes us back to what the question was. Let's just test one more. If I multiply out here, firstly you multiply the brackets and then multiply the 4 after. A multiplied by a will give me a squared. A multiplied by -2 will be minus 2a plus 2a, then minus 4. You can already see that the middle term is going to cancel. If you multiply inside with the 4, then it will give us 4a minus 16. Similarly with this one, it's the very same thing. You multiply inside, I get a squared minus 4, and then you multiply this with the -4, it will take you back to that particular question that we had there. So always try to test your answer after factorizing. All right, guys, that's it from me. I hope you are enjoying and you are learning so much from me as much as I'm also enjoying, and I'm really learning from myself as well. But for now, let's just take a quick ad break and we'll be back with some more. Hi guys, welcome back to our lesson for today. So we are still trying to look at factorizing rules. Right now we're going to take it further to what do we mean when we say something is a trinomial? And what are these guidelines that we need in order to solve a trinomial? So let's just look at it. All right, so firstly we must talk about what is a binomial before we can even move on to a trinomial. A binomial will be an expression of the sum or the difference of two terms. Because of the bi, it's always about 2. When you multiply two binomials, what is it that you get? You form a trinomial. So that's where the trinomial comes from. That's why I said we first look at what a binomial is in order to make sense of what a trinomial is. The last thing about a binomial is these two binomial terms, are the factors of the trinomial. So if I have two brackets like this, and there is a binomial and another binomial here, if I multiply them using the expanding rules, I get a trinomial. This first bracket and this second bracket, we then call them the factors of that particular trinomial that we will get if we were to expand that. So a trinomial will be an algebraic expression. It doesn't matter what the signs are as long as it has 3 terms. It can be plus, it can be minus, not multiply, not division, definitely. So either plus or minus, because as soon as it becomes a multiply, it's no longer a lot of terms, it's just one term, because A times B times C is just one term and not a lot of terms. The most common trinomials that can be factorized have the same variable raised to different powers, right? So you can't say you're going to factorize a trinomial that does not have the same variable and you want to factorize it using binomials. You really cannot. So I have a squared plus 4a minus 12. The variable here is a, so the first exponent is 2, the second exponent is 1, the third exponent, although we hardly write it, is actually 0. Because remember that a to the exponent of 0 is 1. So 12 times 1 is the same as 12. So you can see that the exponents are always in descending order of the variables, not the numbers. The numbers, we don't really look at their exponents. Now, factorizing a trinomial requires you to write it as a product of two binomials, as we saw in the previous slide. Now, let's look at some rules to factorize a trinomial. Firstly, make sure that the order is correct. What am I talking about? Make sure that the exponents are in descending order, because that's the standard form of a trinomial, right? The coefficients do not really matter as long as the variables, exponents, are in descending order, then it is in a correct order. Number 2, always test for a common factor. If there is no common factor, then you follow these golden rules that I'm just going to give you here. You look at the sign of the last term, right? So what do I mean? If I give you ax squared plus bx plus c, or ax squared plus bx minus c, right? These are two examples. One has the last term as a positive, the other one has the last term as a negative. That's the sign you look at, and that's the sign that's going to inform you what nature your brackets are going to be. If the last term is a positive, as my first example there, it means that my two brackets can either be positive and positive or negative and negative. I will tell you just now what determines whether positive or negative and negative. Lastly, my second example, if the last term is a negative, then it means definitely your brackets will be a plus and a minus. And remember, I will still say, my personal view at all times is always try to start with a plus. It just gives you that zing for mathematics, and it sets the tone for you to do the right thing. Now let's go back to the positive one. If the last term is a positive, it means it's either plus, plus, or minus, minus. How do you then determine whether plus plus or minus minus? You look at the middle term. If the middle term is a plus, then it's definitely a positive and a positive. If the middle term is a minus, then it is definitely a negative and a negative. Let me give you examples of what I'm talking about. So, if I have maybe 2x squared plus 4x plus 2 like this, right? Let me just make it 3 so that there is no common factor. The last term is a plus, then definitely my two brackets will be plus and plus, right? Let's look at another example. If I have 2x squared minus 4x plus 3. The last term is still a plus, but now what has changed is the middle term. The middle term is now a negative, so that makes my two brackets to be minus and minus instead of a plus and a plus. But at a later stage, we're going to look at examples in great detail. So let's look at a squared plus 4a minus 12, the example I started with when we spoke about a trinomial. You're always going to look at the factors of 12 in pairs. So I prefer listing the ones on my left in ascending order and the ones on my right in descending order. So it's 1, it goes with the 12, it's 2, it goes with the 6, it's 3, it goes with the 4. In all these three pairs that I have, I must choose a pair such that when I add or subtract, I get 4. I will repeat. In all these three pairs, I must choose a pair such that when I add or subtract, I get a positive 4. So it must either be the 6 minus 2, right? That's the only one really that can be that. I was thinking I can use another example, but that will just confuse us. Then you test which factors can add up to the middle term, as I said. Now, the factors that can add up to the middle term will be the 2 and the 6. So that's what we are going to use in order to then factorize this. Remember, what did I say? If the last term is a minus, what does that mean? My two brackets will be a plus and a minus. I always start with a plus. But now, whenever you have a bigger factor and a smaller factor, the bigger factor always gets the sign of the middle term. Maybe let me repeat that so you can take it down. The bigger factor always takes the sign of the middle term. So it means this will be the plus and that will be the minus. Why is that the case? It's because I want that when you add them and subtract them, you must get a positive 4. So if it became plus 2 minus 6, this will give me negative 4, you see. So it is not what I want. But what I actually want is minus 2 plus 4, which will, plus 6, which will definitely give me a positive 4. I was already thinking of what the answer is supposed to be. And now we use the associative property for multiplication, remember. It states that when 3 or more numbers are multiplied, the product is the same regardless, right? So you always look at the associative property when you're trying to factorize a trinomial. So you're always gonna group them and use the the parentheses or brackets to group these numbers, right? And this is one type, again, of factorizing under a trinomial. That's why I'm talking about the associative property. You identify the same common factor, number 1. You make sure that each bracket is in its simplest form. So I have one bracket which is 3x squared plus 2x. Another bracket which is 12x plus 8. I must take out a common factor in each bracket such that what I will remain with in the bracket is the same in both the brackets. So the common factor of the first one here will be just x, and then in the brackets I will have 3x plus 2. The common factor of the second one will be 4, and I will be left with 3x plus 2. And you can already see that that will then be my common factor as well, with the 3x plus 2. Hence, when I factorize this, it will then give me x plus 4, 3x plus 2. And that's how you will then factorize using what we call grouping. Then the last two things that you just need to look at quickly will be the sum of two cubes and the difference of two cubes. So this is just something that I thought if you were to just jot this down, it will form a rule on how to then factorize a sum of cubes. If it's a sum, the first bracket that you're always going to write will always have a plus, and then the last term of the bigger bracket will always be a plus. And then lastly, the middle term of the trinomial, or rather of the other bracket, the bigger bracket, will always be the different sign to the sum that is there. And for the difference of this, it is more or less the same rule that we are using here. If it's a minus here, the first bracket must be a minus. The second term there will always be an opposite of that, meaning plus, but the last term will always be a plus. So please just jot down these rules. I will show you when we do examples of how exactly do you then apply this when trying to factorize the sum of cubes or the difference of cubes. But for now, because we've been saying a lot, I will be back just after the ad break to then apply all of this into practicality so we can see how do we apply all these rules that I've been talking about. Stay tuned. Hi guys, welcome back from the ad break. So this is our last segment for the show. Here we are going to apply everything that we've spoken about so far. So let's just look at a few different questions, but all of them are all about factorizing. So let's just look at them. Now, the very first question says factorize fully. Remember, I said with any question, it doesn't matter whether you are using common factor or what. You always start by looking for the common factor before you can even do anything. So here, if I look for my common factor, the common factor here will be 5. So I will have 5 into x plus 2, plus 1, x plus 1 all squared minus 25. Okay, now I'm writing my own things. I don't know where I'm taking these numbers that I'm writing here. 25, right? And then you close the bracket. Why am I using a square bracket? Because I have another bracket inside there. So I don't like having a lot of round brackets because you end up not seeing which one is which. And then inside the bracket, if this is too difficult for you, you can then just say let the x plus 1 to be equals to k, or let it be something. It doesn't really matter what alphabet you use or what variable you use. But if you really look at this, it is the same as k squared minus 25, which is a perfect square minus a perfect square. So what is this? It is a difference of two squares. So already you can see that you'll have two brackets that are exactly the same but with opposite signs. So this will be 5. I open my bracket there. I will have x plus 1 in the bracket minus 5 in one bracket there. And then I open another one. It will be x plus 1 and then plus the 5 there. Close that bracket. And then you will need to simplify inside the bracket because remember, you always need to make sure that your brackets are in the simplest form. And therefore, this will then be 5, open the bracket, x plus 1 minus 5 will be then x minus 4 inside brackets, and then the other bracket will be x plus 1 plus 5 will give me x plus 6. then I will close the bracket. I don't really need to multiply the 5 inside, because then that's just me reversing everything that I've done, right? Remember, the goal was to write this as a product of the two binomials. Another example, although this does not look like it is a difference of two squares, it is actually a difference of two squares. Why? The 64 is a perfect square, the x to the exponent of 4 is a perfect square, 49 is a perfect square, and the y to the exponent of 2 is a perfect square. Now, the other thing that I just want to quickly explain, when you talk about a perfect square and you're talking about a variable, as long as the variable is to the exponent of an even number, we always say it is a perfect square. Why? Because a perfect square is a number such that you can multiply two numbers and you get that number that we are claiming is a perfect square, right? So let me make an example with maybe x to the exponent of 6 so that we see this. Remember, if I have x to the exponent of 6, I can multiply x to the exponent of 3 with x to the exponent of 3. But I know that you will quickly want to multiply those 3's. You can't do that. According to the laws of exponents, I must add my exponents. So it becomes x to the exponent of 3 plus 3, which is x to the exponent of 6. So as long as the variable is to the exponent of an even number, then we call it a perfect square. So to factorize this, is there a common factor here? No, there is no number that is divisible in 64 and 49 without leaving a remainder. Similarly with the x and the y. So the factors here of 64 will be 8 and 8, and the factors of x to the 4 will be x squared. The factors of 49 will be 7 and 7. The factors of y squared will be y and y. And then remember, I always start with a plus, then a minus there, but it doesn't really matter which one you start with. And then you look at the bracket that has a minus, whether it can be factorized further. 8 is not a perfect square, 7 is not a perfect square, y is not a perfect square, so that's our final answer. Now this is a trinomial. Remember, I said you look at the sign of the last term. If it is a negative, it means my two brackets will be plus and a minus, right? And the middle term tells us which bracket must be a negative, the one that has the greater factor. So I open my two binomials. I will have x and x. The factors of 4 such that I get 3 will be 4 and 1. Excuse me. And then remember, it must be plus and minus, but where does which go? The minus will go to the bigger factor because of the middle term. So that will be minus there, and that will be plus there. And that will be the factorized part of this. Now, just to quickly show you the method that I spoke about before we got here, I said you look at 4, and the factors of 4 is 4 and 1, 2 and 2. But you can already see 4 and 1 is the only one that can give you 3, because 2 and 2, it's either 0 or 4. It will not give you 3. So that's how you can list them if you want to employ that method. Another example here will be 2x squared plus 5x plus 2. 2 is just a prime factor, right? You know that. So it has 2 and 1. And another 2, it has 2 and 1. But the goal here is to always multiply those 2 and get a 4 there, right? So what does this mean? It means the middle term here is going to be 4x plus x. That's how you get it, right? And then you can use that to try and factorize this. So I will make this 2x squared plus x plus 4x plus 2. And then the first two terms have a common factor of x, which will give me 2x plus 1. The second two terms also have a common factor, which is 2, and that will give me 2x plus 1. So you can already see that this bracket and that bracket is a common factor, which will give me 2x plus 1 in one bracket and x plus 2 in another bracket. And that will be the factorized version of this. So I know that some people prefer this method of breaking down the middle term. It's all good and well, but try to employ it especially when the first term has a coefficient that is not 1. Now here this is factorizing by grouping. The first two terms have a common factor of a. This will be x plus 3. And the second one has a common factor of 2, which will be plus 2 into x plus 3. Then you can see I have two brackets that are the same, which is x plus 3 into a plus 2. And that will be how you factorize this. Now, this is called the difference of cubes. Why is it a difference of cubes? Because 8 can always be written as 2 to the exponent of 3. The same with the 27, it can be 3 to the exponent of 3, and this will be b to the exponent of 3. Remember the rule that I said you should write down. If I have a cubed minus b cubed, to factorize this, it will always be a minus b into a squared, the opposite of that, which is plus ab plus b squared, right? In this instance, our a is 2, our b is 3b, right? So it means that if I want to factorize this, the first bracket will give me a minus b, which is the 2 minus 3b. The second bracket will be a squared, which is 2 squared. ab is 2 multiplied by 3b, so that gives me plus 6b. The last one is b squared, which will be the 3b all squared, and that gives me plus 3 squared b squared. And then you just need to quickly simplify this because, so you will then need to simplify this. The 2 squared, you can't leave it as 2 squared. The 3 squared, you can't leave it as 3 squared. So this will be 2 minus 3b in one bracket, and then here it will be 4 plus the 6b plus the 9b squared. And that will be the final answer there. Now, make sure that you always collect like terms, right? When you are trying to factorize, always also look for a common factor. It does not really matter whether it's a trinomial or what. You start with a common factor first, and then you identify the type of expression, and then you follow the rules, right? So firstly, make sure you take out a common factor if there is a common factor to be taken out, and then apply the rules. You check your answer or you have factorized correctly by expanding those factors using the expanding rules that we did previously. And really, guys, that's all that factorization is all about. Remember, there's 4 types of them, and if you do follow all the rules that you've been doing and maybe you've taken them down, I promise you will be able to do this correctly. So from me to you, the Maths Doctor, remember, mathematics is food for the soul. Until next time.